problem that I created and I wanted to solve using ChatGPT 5. You know that ChatGPT 5 has like different engines, like the flagship model, the Thinking, and the Pro. And I use a combination of Thinking and Pro version to get the results that I want. So you know that one of the typical problems that we have in Revit is that you need to create sleeve drawings where it shows the location of sleeves inside your typically concrete elements, and you need to add dimensions and you need to add tags and to create sleeve drawings, to have like kind of dimensions, okay, from the, I don't know, center to the closest grid, and put these dimensions for all of these things. And usually these mechanical and electrical elements are coming from linked files, and you need to just bring the link model into your structural model, and then start doing your drafting efforts inside that. So one of the big efforts is to just create these drawings, and inside this process, you need to add dimensions. So you can see how ChatGPT 5 and asking the right question and create a good prompt can be resulting in effective and accurate answers. So first, what I did, I asked ChatGPT Pro that, okay, I want to share my kind of draft version of the prompt, and you can just customize it in a way that you understand it better. So I used ChatGPT to write a prompt for itself. So this is the problem statement that I wrote, but this was the problem statement. Okay, I have a Revit project. As a house model, the model has a wall element inside it. My version is that, and I want to do these tips. And here is the detailed prompt version: goal, inputs, requirements, and whatever it wants to do. And then I put this one as the prompt, and asked ChatGPT to just start creating that Dynamo. So I would like you to write a Python script in Dynamo for Revit, and here's the prompt. The goal is, in the active view, plan or elevation of a hospital, place 2 orthogonal dimensions for linked pipe elements, and then it starts, thinking and generating the Python code, and here's the result. So we can test it together. So if I let me run Dynamo. So if I go to manage and start Dynamo, so we wait until Dynamo is loaded. So meanwhile it is loaded, I just want to emphasize that the style and the way that we write the prompt in any AI tool is significantly important for the results that you will get. So let me bring Dynamo here. So it's just simple. You see, first we need to just create some reference plane at each intersection. So you see we have that kind of pipe or duct or conduits, or even fabrication, MEP fabrication, ductwork and pipework elements. And what I ask the ChatGPT to write for me is just, okay, first, find the elements, find the link instances, and then create reference plane at the intersection of each mechanical and electrical element. So if we go back to Dynamo, you see I use this node. This is the Python node that ChatGPT created. So I ask him to just provide the dyn file for me, so which is amazing. So you see it creates this nice and organized script, and I can show you how it looks like when I open that. So this is the kind of Python scripts that it has written for me, with all the details, very organized. all the functions that it creates for me, and then it generates the dym file, which kind of contains that Python script inside that. So we have a bunch of kind of required fields. So here I just need to select the. Let me put my screen like this so we can see the role as well here. I guess I don't need this and I don't need this. So I can. But this is my wall here, and I just need to select my wall element, and then the rest is okay. So we get the current document, we collect the rings using the crumple node, and then we flatten it, and then I'm just looking for all those links that are loaded, and I just use a filter mask on it, and then we feed the Python with the host elements, we feed it with the Revit link instances, and the rest are just kind of um, actually optional fields. Also, we can here add a boolean for this one, and this one is, I think by default, is true filter to elements that are visible in the active view. So we don't want to, create reference frames for some of the elements that are not visible, but by default is true. So we don't need to add a note to that. So if I run it, you see it generates the reference plane and it properly named them. You see this is the reference plane that it creates. This is the reference plane, and also for the dots. So I use the center. And then what I need is to just add the dimensions. So if I open the other Python that it generates, which it doesn't need any required input. So because it already have you see the reference plane that has the name of pen RP, which the previous node generated. So it collects all the reference planes. So, but you can just link this Python node to the first script that I showed you, and then it can be fed by those kind of reference planes as a list of input, and the rest is kind of optional. So now if you look at my screen, I have 2 grids here and 4 levels, and if I run this, you can see it generates all the dimensions automatically and put them properly, and you just need to manually adjust the location of that. So you see that it generates dimensions, one vertical and one horizontal, finding the closest level and grid kind of location in your view, and it generates that kind of information. And also, you can do the same thing with a floor plan as well. So if you, I put some, I think, pipes on a floor plan as well. You see, here's what was the result when I run this on a floor plan element. And it also, if you have a floor plan like a slab that has some kind of sleeves, then you can manually add this dimension. So this is just can be a start. See how good writing how a good prompt can lead to a good result. So you can now kind of bundle this with, I want to tag the sleeves with their diameters, and then create a very wonderful and stable program, all based on Python, and start using that in your team. Hope you enjoyed that, and see you in the next videos. Goodbye.